Hello, everybody, and welcome to Unit 10, Day 0 Notes. And this, we're going to start radicals today. So the radical sign is this sign right here. Let me get a little bit bigger highlighter. I don't know why my highlighter is so small. Is this right here. This is what we call a radical. Okay, anything with this square root is a radical, okay? And that's what we're going to be dealing with today. We're only going to be dealing with radicals or square roots. We're not going to be dealing with cubed roots or anything like that. But, I mean, those are a thing too, but we just don't cover that in this class. So let's just start off easy. We're starting off, hey, what is this question? And we're simplifying all these, and we're putting them into exact answers, okay? That's what we're looking for, exact answers, not decimal approximations, exact answers. We already talked about decimal approximations. You put them into a calculator, they give you some kind of decimal. We'll talk a little bit about them just to show you the difference, but we're dealing with all exact answers for this unit, so that's what we're going to talk about. All right, the square root of 25. Well, the square root of 25 is just 5. You can actually just put that into a calculator. And I recommend for all of these, you do try to put it into a calculator because you never know if you're not good with perfect squares. And this is what we call a perfect square because 5 times 5 is 25. Therefore, the square, is 25. Therefore, if you take the square root of it, it's going to be 5. And that is a perfect square. All right. The next one is the square root of 49, okay? Square root of 49, again, is another perfect square. It is just 7 times 7, okay? If you take it down here, 7 times 7, hey, that is just 7. Woo, we have an exact answer. Okay, great. But what if you get to one like 36? Obviously, 36 is a perfect square, but what if you don't know it's a perfect square and you don't have a calculator handy? How would you go about finding out if it's a perfect square? Well, I'm going to show you right here. And we do these by factor trees, okay? And we're going to get really good at these factor trees because, yes, there is an easy way to find exact answers on radicals, but I want to go down the simplest step first before we get to the more difficult ways to do it. And this way is just to make a factor tree. If it is even, you need to start by making a factor tree by dividing by 2. Okay, it's just the easiest one. If it's even, automatically divide by 2. I have another even number here, so I'm going to go ahead and divide that by 2 again. Next, I'm going to go down to 9. 9 is not a even number, but it does have factors of 3. So what I did is I broke this 36 down into a factor tree, down to prime factors, meaning prime factors are numbers that cannot be broken down any further. So 2 and 3 are prime numbers, therefore they are prime factors. Okay, next I'm going to circle the pair of numbers. You see how there's 2 pairs of 2s? Well, I'm going to circle those. Next, you're going to come to 2 pairs of 3s. I'm going to circle those. So this is a little bit of a game like Go Fish is what I recommend this, or how I kind of analogize this to. So you have a pair of 2s. These come out and they make 1, 2. And the reason why it's a pair of 2s because we are looking at square roots. If we were looking at cubed roots, we would want to circle pairs of 3. If we were looking at roots of the 4th power, you'd want to circle 4s. But here we're doing square roots, so we're going to only circle 2 of them. Again, with the 3s, these are going to come out. And what's going to happen here is these are going to multiply on the outside 2 times 3. Sorry, not 2 times 3. I got ahead of myself. 2 times 3. So therefore, the square root of 36 is 6. Okay? That's how you do these factor trees. That's how you get to an exact answer without using a calculator. We are about to do that on some more of these problems. But these next problems we're going to do are not perfect squares. So we are going to have to use this factor tree method. So let's go about it. All right, 48. if you put this into a calculator and you just hit, hey, second x squared, 48, and you're going to get something that looks like this. Okay, I do not want this for this unit. We are not looking at decimal approximations. We are looking at exact answers, okay? So what does an exact answer look like on something that's not a perfect square? Well, in order to find this out, what you need to do is you need to start by breaking this down, starting a factor tree. So that is what we're going to do. 48 is 2 and 24. I chose 2 because it is prime factor, but it is also an even number, so let's keep going. 2 and 12, 2 and 6, 2 and 3. So again, I'm going to circle pairs that are going to come out kind of like a Go Fish game. You have a pair of 2s, you get 1 point, right? Okay, and I'm going to box the singles. Okay, the singles stay in a box. Okay, so these 2 come out outside the radical. Okay, they are free now because they had a pair. You know, they are now allowed outside the radical, right? But the single stays inside the radical. Okay. Now, my final answer is 4 square root 3. And if you actually put this into a calculator for square root 3, you should get the same exact decimal you got to begin with. And it is, yay, I just put it in a calculator, we did it right. Okay, great. This is how you find exact answers. There is another way to do it. It's called pulling out the perfect squares. We will talk about that when I come back, but for now, this is the most basic way to do it. And this will get you the right answer every time. So let's do another one. Let's do the square root of 110. But you don't always have to break it down by 2. Yes, 110 is a even number, and I could use 2, but I'm just going to show you that, hey, I can use different numbers if I choose to. So I'm going to use 5 in this case because it can be divided by 5. Okay, 5 is 22 and 5. Okay, next, I'm going to do this. It's 2 and 11. Okay, and I think I got that down pretty well. Okay, and then 5. Okay, what you're gonna note about this, notice about this one is there is no perfect square that comes out. There is no pairs, right? So the square root of 110, you know what the simplified version of that is? It's just 110. Can't be broken down anymore. Okay, I can't find an exact answer. Okay, I do have a decimal approximation, but the exact answer is just the square root of 110. Great. 14 is very similar. Again, you're going to break it down with 2 and 7. What you're going to notice is that the square root of 14, guys, cannot be broken down. It is just the square root of 14. All right, the last one we're going to do is the square root of 96. And this one can be broken down. That means it has a perfect square in it. So let's just go ahead and start by doing that. And in order to do that, I need a factor tree. I'm going to start a little differently. I'm going to start with 3. And the only reason why I'm starting with 3 and not 2 is because I do want to show you that there's different ways to do this, okay? I do not always have to do 2. If you know that there's a prime factor that you'd rather use, please, you can use that as well. 32 is even, so I am actually going to use 2 on this one. And I got 2 and 16. Here, I'm going to have 2 and 8. Here, I'm going to have 2 and 4. And then here, I'm going to have 2 and 2. So now I'm not going to circle pairs that come out. I have a pair right here. I have a pair right here. And I'm going to box the ones that stay in. Okay, we're talking about multiplication.